So welcome. Tell you a little bit about this. This is actually one in a series of lectures. And we at the Keck Institute for Space Studies are very pleased to be partnering with the Division of Humanities and Social Sciences. And we've been doing this for the last 3 years, one lecture a year out of their series, which is called the Exploration, the Globe and Beyond. It's a William Bennett Monroe Memorial Lecture Series. One lecture a year out of that series, we co-sponsor with the Division of Humanities and Social Sciences. So the series is intended to bring together a diverse community, scientists, engineers, humanists, social scientists, artists, and the greater public to discuss the broad theme of exploration, and I think you'll see that today, from antiquity to the present, and from new habitats on Earth to other planets in our solar system. So beyond just the topic of physical exploration, the series also investigates the actual process and the human part of discovery involved with every endeavor where we try to increase our knowledge, improve our lives, improve our environments. So I want to say that we've been very glad to work in collaboration with the director of the series, Professor Nico Way Gomez. He teaches the history of exploration, navigation, cartography, and empire, and the Division of Humanities and Social Sciences, and unfortunately he can't be here today, so I'm actually pinch hitting for him here. Okay, so I'd like to introduce Ron Blom, and what I'll do is I'll just read a bit of his speaker's biography, because if you haven't read it, it's enlightening. So it says, Ron retired from the Jet Propulsion Laboratory after 37 years, where despite being unable to dodge management duties, he was able to have a fun career. And that's something we have in common. I was also unable to dodge management duties, but I'm also having a fun career. So he's worked on data from a number of Earth missions, conducting field work in the Egyptian Sahara, Sudan, Oman, Yemen, China, and Peru, in addition to more mundane locations like the Mojave Desert. He got his bachelor's degree from UCSB, where I'm hanging out a little bit these days, master's from CSUN, and his PhD from UCSB again. So I have a bunch of press releases on him here, and he could talk about many things. If you want to buy real estate in New Orleans, talk to this man, because he does subsistence on the Gulf Coast. But today, he's going to talk to us about climate change, impact on past civilizations, lessons from space data and archaeology. Ron.
Yeah, thank you very much. And I want to thank Michelle and also the person who isn't here today for conning me into doing this, but I think we'll have some fun. You'll notice this isn't, the front of this, the first slide here looks a little odd because it has a large number of names on it, and that's because basically I borrowed data from a lot of people to try and put this together, and I want to make sure they get credit. And I'm especially glad I did this since many of them are in this room. The plan of the talk, if I've cribbed a chart or other data on a particular slide, I put the reference on the slide. So if you want to go dig it out and look at it, you can do that. We'll make the PowerPoint available later. And then meanwhile, I've been pleased and privileged to work with all of these folks over the years. In fact, many of them are probably very glad that I retired, because I would constantly pester them at lunch or in the hall at JPL, and now that guy stopped bothering them. One of the key things here at the very beginning, I guess we'll use this one. One of the questions that I always had as a geologist who got mixed up in archaeology, and I'll explain how that happened, is how we got from this kind of a life to that. And it turns out it's much more interesting than I realized, and we still don't know the real answer, but we can shed some light on it, and we'll start off looking at some of that. So the things we're going to talk about, first of all, is the end of the Younger Dryas and the dawn of agriculture. The Younger Dryas was the last gasp of the glacial activity. Then we'll look at some stuff in the western desert of Egypt, which at one time was a grassland, or repeatedly was a grassland, but now it's a hyper-arid terrain. The Old Kingdom of Egypt, which may have been doomed by drought. And we'll look at the Mayan decline and Angkor Wat. And in each of these cases, of course, it didn't end all that well. And so then the question is, what can our ancestors teach us, and what's different this time? And one of the things that's different, of course, is we have global data sets. We have amazing collections of information now, and these are things that our ancestors didn't have. And we also have science, a method for analyzing all this data to try and understand what's happening. This is something our ancestors didn't have. But sad to say, I've been sort of shocked by the number of people in society these days who want to go back to throwing virgins into volcanoes to try and figure out what's going to happen next. But one of the, Alan Robach at Rutgers University puts together some very interesting talks. They're available on the web. He came to JPL once about 4 years ago, and he showed this slide. I thought it was very amusing. If you are thinking that maybe climate change isn't really happening, well, here's some people who are getting ready to put their money on it. If you're in the shipping business, if you could drive from Europe to Asia, you would want to do that. It would save a lot of money. So they're actually having now annual conferences on Arctic shipping, which is sort of amazing to me. So far as I'm aware, they're not actually doing this yet, but identifying profitability in Arctic shipping. So there you go. Okay, so on the principal topic here, something to consider, the modern era is special. It's different. Scientists hate things that are special. How did that happen? If you consider the human situation, anatomically modern humans showed up about 130,000 years ago, plus or minus, quite a while ago. Humans migrate out of Africa during wetter phases across the Sahara and up the Nile. The evidence is pretty scant for the early days, but by about 55,000 years ago, there were lots of people moving out of there. They basically covered most of the Earth, with the exception of North and South America, by about 30,000 years ago. These people were every bit as smart as we are, I'm sure, and I think they were also every bit as spiritual. Some of the artwork, both in Europe and in Indonesia, is breathtaking. This is art from the Chavo Cave. You can see a lot of this stuff online now. But this, I think, is interesting. There was no agriculture and no complex societies until about 11,000 years ago. So that's sort of 90% of human history with no agriculture and no complex societies. That seems odd. What happened? One of the things that you don't want to say when you're giving a talk is typical data is shown, because what that means is the best data is shown. Well, this is the best data right here, but it makes it very, very clear. This is a plot of sodium in the GISP-2 ice core from Greenland. And you can see time counting down in this direction. And basically, things are bouncing around. And then when you get right there, all of a sudden something happens. And sodium is basically a proxy for nasty weather. If you go to the beach and it's really, really windy, you get sand in your hot dogs and your potato salad, and you get covered with salt. So basically, the weather's bad out here, and then all of a sudden it calms down. So the climate all of a sudden becomes much more stable. Now, when I was an undergraduate, we would talk about the recent, and you'd sort of arm wave at 10,000 years, because we didn't have a good date for it. Now we actually have pretty good dates for this. Conrad Hewen had a paper out several years ago in Science using sediments from Cariaco Basin, and that combined with some other data, basically he nails this date here down to 11,570 plus or minus 200, and it seems to be a pretty good date. So something happened there. Okay, here's some more of the data, and if you like data, there's plenty of it to look at here. This is from Richard Alley's Proceedings of the National Academy paper from several years ago. And basically, you can see all of these data sets from the ice cores show that something interesting happened, and it's obviously very important. In terms of how long it took, there's a paper by Taylor from back in 97, and it seems that this transition took place over about 40 years. Now, some people, when they talk about climate change, they say, well, you don't have to worry, it's going to be slow, nothing much is going to happen. But this shows that, at least in this case, it happened relatively quickly. This could really mess things up if it happened now. Another part of this that is worth mentioning is our ancestors dealt with changing sea levels. In this case, we've got thousands of years ago, and the time goes this way. Oh, on many of the slides, the time direction reverses. So keep an eye out for that. I'll try to remember to point that out. But most people don't think about the fact that in a geological eye blink, 20,000 years ago, sea level was 120 meters or more lower, close to 400 feet. So when you go to the beach, from a geologist's perspective, when I go to the beach, I see a landscape that's still not in equilibrium with the present sea level. So if you look at this, you'll see that sea level was rising rapidly as the glaciers were melting until about 8,500 years ago, when it sort of stabilized, and at this point it started going up very, very slowly. So this was something else that was going on at the same time. In terms of geography, this makes a huge difference. This is northwestern Europe, United Kingdom, and Netherlands. Basically, during the Ice Age, you could walk from France to Britain to Ireland, take a hike. So, and in fact, fishermen were mystified for years, particularly on the Dogger Bank. They were bringing up obvious tools and things like antler racks and other things in their fish nets. They didn't understand that in the old days. In any case, the point is, if you change sea level a little bit, it really changes things a lot. And particularly if you consider the fact that, I showed the shipping slide at the beginning. What is the altitude of every port on the planet? It's at sea level. If you change it a lot, it's going to be a problem. Okay, so what's happening with sea level now? This is tide gauge data from starting around 1880, and you can see that it's going up again. It seems to be accelerating. In fact, it is. If you just look over the whole time period, it's about 20 centimeters. But if you look at this a little more carefully, you realize there's actually multiple phases here, and it's actually been accelerating over the most recent time period. This could be a problem, and of course we know where this is coming from now. Oh, and as an aside, the expert on all of this stuff is a fellow by the name of Stan Church at CSIRO. He's getting laid off. If you want to get in the realm of bureaucratic stupidity, the Australians have decided to close down that program, apparently. I'm sure he'll get another job, but it's an amazing thought. Okay, so lots of people have negative opinions of tide gauges because they're typically in harbors or other places where they're easily disturbed and your data may not be good and who knows what. But there's other ways to do this. Now we have satellite altimetry, and this is in the realm of technological magic, I think, because you look at the surface of the ocean and it's got all these waves and things on it. But we have satellite altimeters, and we've been operating these since 1995. There's been 3 different satellites with these altimeters on board, but sensibly enough, there's been overlap in time for each of the altimeters so that they can be cross-calibrated. So if you put all this stuff together and analyze the data, you can see this is from just last May 6th. The answer is almost identical to the tide gauge answer. In this case, we've got 3.4 millimeters a year. And I don't know, it looks like maybe it's accelerating again. So maybe it's changing state. In any case, sea level is going up. Oh, and another important point, roughly a quarter of the sea level rise is due to the warming of the ocean. Everyone talks about global warming, worrying about the air temperature, but in fact, something like 94% of the heat is actually going into the ocean. So this is something we ought to be thinking about, I think. Okay, moving to what happens with humans at the end of the Younger Dryas. This stable climate, that was new to humans. And it didn't take very long for people to exploit this. There's been at least a couple of papers on this. The chart here is actually an adaptation of the paper from Feynman and Rusmaikin, and they're here. Good to see you, thank you. The key point here is that as soon as the weather calmed down, people started doing agriculture in different places, and they had different resources to start with. There were different grains and different animals, but they all figured this out fairly quickly. they couldn't, of course, send tweets to each other saying, hey, try this. So these are truly independent inventions in different places. It was suggested that it took a little bit of time to get agriculture going, but it seems that if you were in the right place, it happened almost instantly. This is a recent paper by Wilcox in the Near East. The significant thing here is that the green dates are use of grain without cultivation, and the blue dates are the first evidence of large-scale cultivation. In other words, they were farming. And you scan this thing, and basically all of the cultivation dates are immediately post or somewhat post Younger Dryas. So in this area, folks figured it out really quickly. A peculiar thing here, they may have had a head start because recent archaeological work has shown that there were, in fact, permanent settlements for some hunter-gatherer societies. They were living in an environment that was sufficiently rich that some of them could stay put. And there were two of those in southern Turkey that I know of, and also one in Japan, the Jomon culture, which actually had pottery before they'd had farming. So there's some interesting new work that's coming out. In any case, the point is farming starts immediately after the climate settles down. So how did a geologist from the Jet Propulsion Lab get mixed up in this stuff? And this was really my start in it. In 1981, JPL had a instrument on board the second flight of the shuttle called Shuttle Imaging Radar A. The principal investigator of that mission was a guy you might have heard of by the name of Charles Elachi. This is the Surrey antenna here. The mission was shortened because of a problem with the shuttle. We only got a 2-day mission instead of the promised 4-day, and that turned out to be a benefit in hindsight. We basically took data anytime we were over land with the instrument, and one of the strips that we got was this over northeastern Africa, so coming across Sudan and into southern Egypt. When we first looked at this data, we actually, the data couldn't be sent down. This was actually not digital data at the time, and it was processed after the shuttle landed, and we were actually quite confused at the very beginning because this is the radar image, the Surrey radar image of the western desert of Egypt, and it's laid down over a Landsat image. This is very old data, of course, so it's not that high quality, but I think you get the idea. This is a massive desert, but you can see right away that there are stream channels in this radar image. We thought perhaps that we'd mislabeled the thing or something, but after conversations with the U.S. Geological Survey folks who were working in this area, we realized that something very interesting was happening. Basically, in the very dry sand cover here, the long wavelength radar is able to image through the sand and see the landscape beneath. So naturally, we had to go out there and see what was going on. So we piggybacked with the U.S. Geological Survey folks. And here we are. This is a very much younger version of me in front of the most Hollywood-like oasis we found. Most of them don't look like that, by the way. This is Jerry Schauber and Jack McCauley of the U.S. Geological Survey, and I regret to report I've forgotten this chap's name, but the Egyptians, of course, were absolutely vital to keeping things going. And here we have Jack McCauley again. By the way, Jack McCauley was instrumental in helping plan Apollo lunar field plans for the astronauts. And Maurice Grelier, and here's a very much younger Charles Elachi. So anyway, today the Sahara is one of the driest places on Earth, but back then, or 7,000 years ago, it was a grassland that was intermittently drying out. Okay, so here's what's going on with the shuttle, basically, or the shuttle imaging radar. The radar sees this surface here, while the surface you see with your eye and the surface you walk on is this one up here. So the radar actually behaves a little bit like a time machine in this particular location because it shows you a landscape that was carved in earlier times. here's an enlargement of one of the radar scenes, and if you look at this, this is basically a large river valley here, now dry, of course. And if you look very closely, you can see smaller ones within this drainage. And this is, of course, also dry now. Oh, in terms of size, this is about 50 kilometers across, so this is fairly large. So here I am standing in that little drainage, and if you're there, it's difficult to put all the pieces together without the image data. If you have the image data, you can see, you can get an integrated picture of what's going on. But here there's a little river channel, former river channel coming in and meeting this slightly bigger one, and there's a jeep up there for scale. The jeeps, by the way, at the time were Russian jeeps. The Egyptians had just sort of gotten a divorce from the Russians, but still had a lot of equipment left over. And in typical Russian fashion, the jeeps were very tough and solid, but they had some interesting features, like the windows didn't roll down. You could unbolt them, so that was your morning decision. Do I want to unbolt the window, in which case you eat dust all day, or do you want to sweat? Anyway, if you dig a little bit in the river, you find these rounded pebbles. So obviously it is, in fact, exactly what we thought it was, an old stream channel. But anytime we got near any of the radar rivers, we started finding lots and lots of artifacts. Basically, they'd be all along the banks of these rivers. So it was clear that a lot of people had spent a lot of time there not long ago. Now, I want to make a slight detour out of the climate topic for a second, because after, I think Michelle actually wanted me to talk about this instead, but we'll do that some other time. We got, after the survey results were published, we got a lot of very strange phone calls and letters. This is in the pre-internet days, of course, so you know you collected up some unusual things in the mail. One of the calls, I seem to be the designated guy to send some of the odd people to, and one of the calls I got was from a documentary movie producer by the name of Nicholas Clapp. And in talking to him, it was clear that this guy had actually done a great deal of homework. He'd spent a lot of time in the southern Arabian desert, and he had this weird story about a supposed lost city buried in sand out there, and he brought various data to support this idea. And I managed to run this idea past Charles, who was like, well, okay, if it doesn't consume any resources, yeah, go ahead and set up some shuttle observations of the area. So that was the original plan. Oh, and how did we think this had any basis in fact? Claudius Ptolemy actually created an atlas of the known world at the time, and here's a cartoon of him. He's holding the Earth. He obviously knew it was round. He set up his own latitude and longitude system, and if you look at these sites, for example, here's Medina. These are mostly places that are known today, and Omanum Emporium, the Latin name for the Ubar site, is in the list. The reason for having this place in the desert would have been for frankincense. This is a frankincense tree. They grow where almost nothing else does. Frankincense is the resin from the frankincense tree, and in the ancient world it was extremely valuable. Most of it comes from all of it at the time came from southern Arabia, and Rome was a fantastic consumer. For example, the Roman Emperor Nero is supposedly consigned an entire year's production of frankincense to the funeral pyre of a wife that he'd almost certainly murdered. Okay, so the story gets really great because it's a real Sodom and Gomorrah story. The people at the Ubar, in the region of Ubar, were getting very wealthy, selling frankincense. It's a little bit analogous to the situation with petroleum these days, where you have an area that has a lot of the resource, but a small population. So anyway, a lot of money to be made, so a lot of crazy stories came out of it, including the fact that the site is now guarded by these charming fellows. Years ago when I gave this talk, I used to say that they didn't scare us because they looked like the clerks at the music store where I used to buy my music. But of course, nobody buys music anymore, so I don't have a good joke for this one anymore. In the 30s, there was a British explorer who was in the area, Bertram Thomas, And he wanted to be the first Westerner to cross the empty quarter. His competition to do this was a chap by the name of Philby. If that name sounds familiar, the Philby who wanted to be the first to cross the empty quarter was the father of Kim Philby, the notorious British spy. In any case, Bertram Thomas played a few tricks on Philby and managed to arrange to get himself across the empty quarter first. So here he is with his Bedouin companions, who are the guys who actually knew how to get across the desert, not Bertram. He wrote a very charming book, which includes this map. And when he was out on the edge of the sand, he found some tracks. And his Bedouin companion said, "Oh yeah, those are the tracks to the Ubar site." So we in fact had a few good ideas of where it might be at the outset. The Challenger accident happened, and that sort of interrupted the shuttle radar program, leaving out a lot of details. We ended up using satellite data to locate tracks. We discovered that carefully processed data using processing techniques developed by a good friend of mine, Bob Crippen, who's out here somewhere. We were actually able to see these tiny, what are now pretty minor tracks, better on the satellite data than we could on the ground. So ultimately that led us to all the tracks came together at one site, so that clearly was an important place. The archaeological ruins there were exceedingly modest, but it makes sense because it was really just a gathering place for caravans. It was a starting off point for caravans crossing the land route with frankincense. Pliny, in this case, writes of 8 fortresses on the desert trade route, and this is the easternmost of that lot. We actually went and looked for others, and that's a different story. This is actually a ton of fun. Nick wrote a book about it if you want to read about it, The Road to Ubar, published in '98. Okay, so let's switch back to the climate track for a minute. Both the Arabian Peninsula and the Sahara had similar climatic things going on. Basically, waves of green would come and go depending on the climate. The most recent one was from about 10,000 years ago to a little less than 7. In this case, time is going this way. This is actually a fairly complicated graph from Cooper and Kropelin. This is latitude over here, and I think it goes up to 29 degrees. For reference, Cairo is at about 30. So at about 7.9 thousand years ago, the Sahara was inhabited. It was green. People were living out there. All these little symbols show the different types of archaeological and other remains that are there. So it was a busy place then. Then it started drying out, and you can see how it dries out over time from north to south, exactly what you'd expect. And so then the question becomes, where did the people go when the Sahara dried out? Of course, they retreated south or they went to the Nile. So that takes us to the next topic. I have a few slides here from a friend of mine, Sarah Parkhack. I first met her when she was a graduate student. She's very talented and also very aggressive. She's done some pretty interesting work. I think she got herself in trouble in Egypt because there was a film crew brought in, I think, without Bahei Issaway's approval. It got smoothed out, but I noticed her most recent work is actually in Newfoundland looking at Viking sites. So I don't know if they're still working in Egypt or not. Anyway, so these slides are from Sarah. She did a lot of work in Egypt. She was very enthusiastic about using any type of remote sensing data she could because given how rapidly areas in Egypt are developing, she needed to find the sites before they got paved. And then, of course, the second part of it is how do you have to assess what time period and things like that. And just to show that she will go use very old data if necessary, this is a very old Landsat image of a place near the coast called Tel Tabila. And this ugly looking black and white thing is actually a Corona spy satellite image from the late 60s. And the reason you want to use something like that is because, of course, you can always go somewhere, but you can't go some when. So if you want to know what it looked like many years ago, this is the data to go for. This stuff was classified for years. It's now available. It's all been digitized, and you can actually download this stuff online. If you're interested in the history of technology, this is also a very interesting system because they had no digital transmission in those days. The data was actually recorded on film, and the film was ejected from the spacecraft in reentry capsules and then caught in the air by aircraft. So this is a thing that if somebody said, yeah, this is how we're going to do it, you'd go, no, that'll never work. But it did. I think there's even YouTube film video of some of the capturing of some of the stuff. Oh, and the reentry capsules had salt plugs in them so that if they missed them and they landed in the ocean, they would sink before the Ruskies got there. Okay, so this is just an example of Sarah's data. And what she's plotting up here are the number of sites by time, this rather cryptic thing, in a given grid. And the important point here is that this blue line, where there's lots of, a goodly number of sites, is for the Old Kingdom. And this first intermediate period, which immediately follows, there's obviously a lot fewer sites of that time period. So what's going on? One of the problems with the Egyptian government is, of course, the pharaoh is supposed to be a god. So if things go bad, then it's not going to be good for your pharaoh. And it's a little bit hard to see this figure up here, but basically this is a plot of Nile flow over time, and right around the end of the Old Kingdom, it gets very low, and then it gets disastrously low. And this corresponds with a variety of problems in the area. Archaeologists tend to not like this environmental determinism stuff, but I think in this case it's fairly clear that bad things were happening. This is a figure from a paper by Stanley and others in 2003, and he's using strontium 7:6 ratios, which are a proxy in the case of the Nile for flow because the waters come from different sources. And basically the key thing here is one of the lowest flow periods in the older times was at the end of the Old Kingdom. So what probably happened here? Well, I like this slide of Sarah's because if you read her list of things here and then think about the present world, some of this stuff is exactly what's happening in some places now. It's sort of amusing. The growing impoverishment of the royal court, tax exemptions and furnishing and maintaining cults, and wealth and power to the provinces, governors residing in the provinces. And this was a real problem that they had. They were unable to redistribute the grain from areas that did have a surplus because the local governors didn't, why should we give up our goodies to our neighbors? And of course, the pharaoh was in trouble anyway because obviously he wasn't in good with the gods. Oh, and of course, it's bad for everybody else surrounding the Egyptians as well. So they're trying to come in and get something from what's obviously a wealthier society. So there's lots of people invading, and so things are not good here. Then, of course, there's a succession issue. So the end of the Old Kingdom was actually part of what was a global climate event. And there, if you look in history across other complex societies at the time, many of them had trouble even in the New World. So exactly what happened here isn't clear. It probably relates to ocean. Everything, you can blame everything on the ocean because that seems to be the case. But exactly what happened here, we don't know. Okay, moving forward in time and to a different continent, Dan Irwin and Tom Seaver, who were at the NASA Center at Huntsville, and Tom has since moved off to the university, They've been working in Central America for a very long time. Their real job is setting up this environmental monitoring and support system. If you go to the Surveyor website, there's a lot of data there that you can download and help yourself to. But Tom is actually one of the few, in fact, I think he's the only real archaeologist that NASA ever had. And he did his PhD work with Pace and Sheets and spent some time working on the Maya, which is really his main interest. So this is an example of some of the data that they have. If you're interested in that part of the world, this is a great resource. But Tom was especially interested in the Maya. Now, the classic Maya period ran from about 300 to 900 AD, so that's a lot longer than we've been around, right? And they were obviously well organized and fairly wealthy, and this is the plot of the cities that are known. There's lots more of them out there. Every once in a while you'll see in the news about somebody who's found yet another one. And in fact, there was one about some young fellow who supposedly found a site using Google, but of course you need to go there. You don't have anything till you've gone there. But anyway, so there's a lot more out there than that. But what happened to these folks at the end of the classic period? Tom once told me that he had made a list of over 100 reasons that people had come up with for what happened to the Maya. And of course, it includes a few ringers like aliens and, you name it. But there are probably two main components to what happened. And one of the things that the more recent research on the Maya has disclosed is that the populations were actually bigger than most people imagined. In fact, this seems to apply to all of these older empires. Archaeologists have a guesstimate for what the population was, but then as more and more data comes in, it turns out there were more of them. So it makes the demographic disaster even more frightening. This is a National Geographic cartoon of what El Meodoro looked like. It's probably a little bit overblown, but even if you remove a lot of it, that's what it looks like today. So I think something happened. Tom and Dan in the early days were using a lot of Landsat data. Even though this is the jungle terrain, they developed some processing techniques that allowed them to see vegetation anomalies that were associated with buildings. That turned out to be a fairly successful technique. They did a lot of field work there, and this was exceedingly difficult. I'll take a desert myself, and I think looking at this, I think I see why the Maya didn't bother inventing the wheel. Okay, one of the problems that the Maya had, and this is the usual profit motive here, they were definitely using their agricultural resources in a non-sustainable way. But you can see the appeal. They had no chemical fertilizers, of course, so their scheme was they would slash and burn, plant, and then let it go fallow for a while and then start over. But they discovered fairly quickly that the number of people that they could support per square kilometer of agriculture went up dramatically if they shortened the fallow periods, and you can see the temptation. And since they did have a very large population, they reduced the fallow periods and basically overextended their agricultural resources. So this is a bad idea. But they were able to maintain it for quite a while when the weather cooperated. Meanwhile, they did have some, they were adept at handling water, and they were able to withstand short-term droughts. But sometimes, like as in California, as we know, sometimes droughts are longer. This is a graph from a paper by Staley and others, and this thing here, this PDSI, this is the Palmer Drought Severity Index. Basically, he's looking at tree rings and assessing the water conditions at the time. And the bottom figure here is an enlargement of each of these up here. And basically, what you've got is periodic 30-year plus minus droughts in these areas, and they correspond neatly with troubled times for each of these civilizations. So there's certainly a connection here. Now, what's driving all of these things, we don't know. Blame it on the ocean again, probably. But in any case, the Maya were certainly, the drought may not have done them in, but it certainly didn't help. So moving to yet another continent and another time period, we had another exercise using data from the AIRSAR system. It's now decommissioned, unfortunately, but it used to fly in NASA's DC-8. It was an experimental radar that was very capable. It had multiple wavelengths and multiple polarizations. It generated high-resolution images and also digital topographic data. In 2000, we had a project called PAC-RIM for Pacific Rim, and basically we collected data in many areas in the Western Pacific. We were very fortunate in being able to collect data at Angkor Wat in Cambodia. Angkor was a major center from the 9th to the 15th centuries. We worked with archaeologists, particularly Roland Fletcher and Damian Evans from the University of Sydney, and also Elizabeth Moore from University College London. The radar data was instrumental in finding additional temples and occupation sites and whatnot. One of the important lessons from the Angkor data was that you needed to look at both the image data and the digital elevation data because they gave you different information that was complementary. For example, in this particular case, the Angkor Wat site is very obvious. In the image data, you can see some of the different features. But there's a temple mound over here that's smaller and older. It doesn't show at all in the radar image data, but it shows up as a high spot in the digital elevation data. Now, ironically, we didn't know that that mound was there, but after we pointed it out on the digital elevation model, the locals, of course, said, "Oh yeah, we know about that." So, you know, it's important to talk to the locals because they often know everything. So the Greater Angkor project at the University of Sydney has been going on, and they now have LiDAR data, which is a game changer, I think, for archaeology. They've made maps of this entire area, and it's much more complicated and much larger than anybody appreciated when they started. In fact, last time I talked to Damian Evans, he suggested that the population might have been 1 million at the peak, and this is a staggering number for a society at that time. As time went on, they suffered many problems. Starting around the 1300, which is incidentally about the start of the Little Ice Age, the monsoons in this area became erratic. And again, you know, the Angkor wasn't the only place having trouble. The surrounding areas were as well, so the tribes started invading. So there's all sorts of social disorder. Because of the erratic monsoon and floods, they had trouble maintaining their irrigation system. They silted up, the rice yields dropped. Wasn't a good thing. So anyway, they were having trouble through the 1300s, and they finally abandoned the site in 1431. There was a Proceedings of the National Academy paper by Evans and others back in 2007, which describes all this stuff. But the most amazing thing to me is this is Damians Map. And you know, you look at that and you go, yeah, okay, I see the canals, I see the large water structures and whatnot. But the thing to notice here is the scale. This is 20 kilometers across here. You could stick 3 or 4 Pasadenas in this area. That's how big it was. So they were, I'm sure they felt they were masters of their terrain and their hydrology. Well, if we look at data that gives us some insight into drought from the immediately surrounding areas, what we find is that there were 2 periods of relatively long drought in the area. The first one around 1350, and then the second one in the early 1400s. And this corresponds with when the Angkor site was abandoned. So there was obviously more than one thing going on here, but again, the drought was probably a key thing, if not the kicker. Now, we could keep this up all afternoon. You can look at many different examples. But I think in summary here, the present period of time has been special, at least from a geologist perspective. 90% of human history, no complex societies, no agriculture. Then relatively rapidly, about 11,000 years ago, it gets invented in multiple places. Meanwhile, you move forward in time and minor climate variations took down or contributed to the demise of multiple civilizations that were certainly the state of the art for the time. It's really unlikely a coincidence that all these social changes occurred at the same time as climate changes. And there's some very thoughtful papers written on this, and drought keeps coming up in both the Domenical and the Weiss papers. And just for your amusement, when I originally put this talk together, I chose the sites based on the fact that there was some remote sensing data that I was at least vaguely familiar with for each of them. And after I did it, I discovered that each one of these examples, drought was one of the key factors that did it in. So considering our current situation in the western US, maybe we could think about that. So anyway, our current climate variations, are they just regional? Are they decadal? Are they local perturbations? We don't know. And I don't think we're planning very well for the future. If you find this intriguing, in addition to the references that are scattered throughout the talk, sort of general interest stuff here, if you're a data fiend, you really want to look at the glacial world according to Wally. There's an immense amount of data in there. I checked this link the other day, it still works. If you need books to read on an airplane, Brian Fagan, who's now Professor Emeritus at UCSB, has written a number of historical novels looking at, well, historically accurate, looking at the relationship between societies at particular times and in particular climate situations. They're actually quite engaging. Anyway, so there's a suggestion for interesting reading. And as far as the future goes, Alan Robach has posted a lot of very interesting stuff, including an impassioned explanation for why geoengineering is a bad idea. He's probably right, but my reaction to that is it's too late. We've been doing it in a completely uncontrolled way for the last 150 years or more. Anyway, so there's lots of interesting stuff to look at if you're, if this topic excites you. And with that, any questions you have?